What we're going to do today is called Properties of Exponents, and you're going to have a booklet to go on your page 57. So this is the only thing that's going to go in your book today. We're on the front page. Let's get through this so that maybe you could have some time in class to do some homework over the week, so you don't have it over the weekend. No. Oh. Solve the following problems by writing them in expanded form. I want you to look at these two problems, the 2 to the third power times 2 to the fourth power. Now, okay, 2 to the third power is 2 times 2 times 2. That's what expanded form means. 2 to the fourth power. 2 to the fourth power means, that's what expanded form means. Now, how many 2's are there? 7. So that is 2 to the 7th power. Wait a minute, did I have to write all that out to figure out that that was 2 to the 7th power, or could I have looked up here and said, oh, that's 2 to the 7th power? By doing what? That's right. When I multiply like bases, all I have to do is add the exponents. You do not have to go through all of this. Go to the second one. Is this 3 to the fourth power divided by 3 to the third power? The answer is yes. Let's write this out in expanded form. Now, before we talk about this piece right here, let's do 3 to the fourth power. 3 times 3 is? I'm going to show you a real easy way to do 3 to the fourth power, because you might not. 3 times 3 is 9. 3 times 3 is, and 9 times 9 is, that's 3 to the fourth power. 3 to the fourth power is 81. Yeah, just give me a minute. 3 to the third power, 3 times 3 is 9, times 3 is 27, and 81 divided by 27, you have a calculator, but it's 3. Now the question is, do I have to multiply all this out and then divide to figure out what my answer is? Now Megan said, well, 3 divided by 3 is 1. 3 divided by 3 is 1. 3 divided by 3 is 1. So what am I left with?
3.
I'm left with 3. Now, but do I even need to write it out in expanded form? No. Because as Gavin said, if I'm dividing like bases, what do you think I do to those exponents? I subtract them. So this is 3 to the 4 minus 3, which is 3 to the first, or 3. Good. Now, I'm going to show you, do you see in that box, those boxes where it says properties of exponents? It says, the first one says product of powers, a to the m power times a to the n power. 2 to the third power times 2 to the fourth power is 2 to the 7th power. So what's a to the m power times a to the n power? No. What did we do to these numbers? By doing what? Adding m plus n. Huh? I want you to write this. Yeah, you leave it like that because you don't know what they are. A to the m divided by a to the n. This is right under where it says quotient of powers. A to the m minus n. Please, 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 these bases have to be the same. Don't forget that. And you cannot do that. Okay. Look at the next one. It says product of a power. Let's talk about this. How do you read that? Okay, so that says 2 cubed squared, or 2 to the third power raised to the second power. Now, there are a couple ways we could think of this. What's 2 to the third power? 8. So that's really just 8 to the second power. But what's 8 to the second power? I don't know what I was doing there. 64. Now, I want you to think of this. Let's get on your fingers. We're going to start multiplying by 2. 2 times 2 is? Times 2. 8 times 2. 16 times 2. 32 times 2. 2 to the sixth power is 64. How could we have gotten from here to here?
Because you multiply 3 times 2.
Right. Now listen. When you raise a power to another power, what do? You multiply those powers. Mhm. So, a to the m power raised to the n power is a to the m times n. We're going to hold off on negative exponent. We'll do that in a minute. Go to the top where it says 0 exponent. Do you know what 2 to the 0 power is? Nope. Okay, let me show you something. You don't have to write this down. I just want you to think with me. We know that 2 to the 4th power in expanded form is this, but as an answer multiplied out would be, what is that? I'm waiting. 16, right. Yeah. 2 to the 3rd power to the 2nd power Now, I want you to look. Look at the pattern. What do you see? What do you see here? What's happening?
It's going down by 1.
The exponents are going down by 1. What happens to get from each of these numbers to the next number? Divide by 2. What's going to be next? 1. 1. But what would the exponent be? 2 to the 0 power is 1. Anything raised to the 0 power is 1. Why? Just what I showed you right here. Math is full of patterns, and this is one of them. We divide by 2. So, where it says 0 exponent, a to the 0 power is 1. Now that next one says power of a product. What was that? Maybe just powered down. You have a calculator. Okay, all right. So we could consider this as 6 to the 3rd power. You have a calculator. (36 times 6) 216. Now, I want you to do this. 216 is 8 times what? Get your calculator. 216 is 8 times what? Now, guess what? 8. I'm not doing a factor tree right now. So I don't want you to think that that's a factor tree. 8 is 2 to the 3rd power, and 27 is 3 to the 3rd power. Right? Look here. How could we get from there to there?
Multiply 2 times.
That's right. That's right. Gavin said, we'll just take each of those numbers and raise them to the third power. 2 to the third power times 3 to the third power. Now, here's the deal. This has to be a product. This has to be a multiply. That's why it says power of a product, because a product is a multiplication. So, what if I gave you this? 4x cubed. What property or what operation's happening between the 4 and the x? No, don't get ahead of me. Multiplication. The 4 and the x are multiplied, right? So I could rethink that as 4 to the third power times x to the third power. What's 4 to the third power? 4 times 4 is 16. 16 times 4, you have a calculator. That's 64x cubed. Negative 2r to the 5th power. That's going to be negative 2 to the 5th power times r to the 5th power. What's a negative number raised to the 5th power? 32, is it positive or negative?
No.
Negative multiplied 5 times.
Negative. Sorry.
What's a negative times a negative? Positive. And negative times a negative? Positive. Now what's a positive times a positive? A positive times a negative is a negative. Odd power, when you have a negative number raised to an odd power, the answer is negative. So this would be negative 32 r to the 5th. So, where it says power of a product, what's a times b to the m power? No, not a times m. A, say it right, a to the power of m or a to the m times b to the m. What do you think a divided by b to the m is? Well, it's a to the m divided by b to the m. Come on, Alex. Now we've got the one that's going to, it's not hard, that negative exponent. It's not hard, I promise, but you're going to mess it up. We're going back here. So we've got this pattern going, right? Got this pattern going, and I'm going to erase this and make it get up there closer. 2 to the 0 equals 1. Now, what would come next in terms of the exponent in our list? Negative 1. Are you with me there? But look over here on the right side. What's the pattern to get from one of these numbers to the next? Divide by 2. What's 1 divided by 2? 1/2. Isn't 1 divided into 2 equal parts a half? Oh. Oh. The next one, 2 to the, what would it be? 2 to the negative 2. Now, if I divide this by 2, go to your calculator. What's a way I can put 1/2 into that calculator you got? 0.5. Do 0.5 divided by 2. It's 0.25, which is a quarter. Now look. Look, 4. Wait, 4. Oh my gosh. 4. 4 is 2 squared, right? 4 is 2 squared. This is 1 over 2 squared. We're going to go one more. We're going to go one more because Dr. Williamson thinks he knows the next one. What's next? What's next? What do you think is going to go here?
1/8.
Because that would be 1 over 2 to the third power. So, oh my gosh, when you have a negative exponent, what happens? Where does it go? And how does it change? Where does it go? It goes to the denominator and becomes positive. It goes to the denominator and becomes positive. Here's what I tell people, and it's stupid, and I know it, and people remember it. No. You want me to? I don't know. Well, all right. All right. Well, I hope I am recording. Yeah. I have 2 to the negative 8th power. That negative 8, that exponent is unhappy where he is. So he says, I am leaving here and I am going to the basement. So he goes to the stairs and goes, rah, 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 and he goes downstairs. And he gets happy down there because he becomes really positive. Rah, 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 rah. He stomps to the basement because he's pissed off. And so, okay. So what happens to this one? He's mad because he just, I don't know what happened. He got grounded. He lost his phone. He got grounded. He says, fine, I'm not living up here anymore. I'm going to the basement. Rah, 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 rah. And so, shut up. So what does this do? 1 over 2 to the 10th. All right. Now, look on, I don't even know. A to the, no, I would, no, because nobody'd come. Okay. A to the negative m.
1 divided by A with.
I would tell you to come up and write it down, but no. We would take too long, wouldn't it? No. No, I love you. I love you, Hayden. I love you, Hayden.
Correct? I don't think that's how
Yes, Hayden's right. Open the booklet. Here we go. Left side of the page. Gentlemen, ladies, left side of the page. This group right here and this group right here doing real good. This group right here doing real good. You're doing good. You're just loud at doing good. You're loud at doing good. That way you can at least pay attention. Number 1, what's x squared times x to the 9th power? X to the 11th power. Number 2, p to the negative 2 power.
1 over P squared.
Number 3, x squared to the negative 3. Now this is combining 2 of the rules you learned on the front page. When you raise a power to a power, you multiply x to the, now hang on, we'll go 2 steps. X to the negative 6 1 over x to the 6th. Number 4, 3xy squared to the 0 power. Okay, which of the rules on the front will we follow? Okay, 0 exponent, fine. What's anything to the 0 power? Be 1. Anything to the 0 power is 1.
Always.
Always. Number 5. 3x squared y to the negative 1 cubed. Which rule? I want you to read me the title of the rule we're going to have to use. Power of a product. Find power of a product. Right, Trey? Power of a product says A times B to the M is A to the M times B to the M. So, now hang on. What things are we multiplying together right here? 3 and, well, hang on. Okay. How many things are we multiplying together inside those parentheses? Shh. Come on, guys. 3 things. What are they? 3 and x squared and y to the negative 1. So we're going to take each one of those and raise them to what power? To the 3rd power. So that's going to be 3 to the 3rd power times, where did you get x to the 6th? Because it's x squared to the 3rd power, right? So that's x to the 6th times y. Remember, this is y to the negative 1 cubed. Just a minute. Now, questions right here.
So then, that has the negative, you have to put all over, like 1 over all of it?
Just the only thing that's going to get mad and go stomp into the basement is the thing that's raised to the negative power, which is going to be y.
So it was 83.
Okay, what's 3 to the 3rd power? So this is 27. He wasn't mad because his exponent was positive. Is the x mad? No, his exponent's positive, so it's 27x to the 6th. Is y mad? Yeah, he's stomping off, going to the basement, and becoming happy down there because his exponent becomes positive. Question. 3 cubed, 3 to the 3rd power, is 27. Please ask questions. Please, please, please. We have one more on that page, number 6. 2x squared, y to the negative 4th, z to the 0 power, all divided by 4xy squared. Folks, we got a lot of multiplying going on here. Ultimately, we could. This one has got a lot of stuff, different ways we could do this problem, okay? Here's what I'd like to look at first. I'd like to look at this. Why would I like to look at that? Because he's mad. Where's he going to stomp off to? He's going to stomp off to the basement. Now, what about this guy? That's 1. So, think about what, okay, so I've got 2x squared. Now, where's that y to the negative 4th? Where's he going? He's going to the basement, so we know he's going to go down here and get positive. And then what's that z to the 0 power doing? It's just 1. Do I have to write down times 1? No. Now let's look at the denominator. Is that 4 happy there? Yeah, that 4's happy there. Is that x happy there? Yeah. Is that y squared happy there? Yeah. He's 1. Yeah, so he's gone. He's 1. Yes. Yes. Now, here's what I want you to do. We have some things that we can clean up right here. What do you say? Well, I want you to think it differently. Think combining like terms as in adding and subtracting. But I can do y to the fourth power times y to the second power, which is y to the sixth power, right? So this is 2x squared divided by 4x y to the sixth power. Do you have any questions? All right. We're almost done here. So now we're going to go to what Sarah was looking at. She was thinking about quotients. Please notice that the numerator, all that stuff's multiplied, the denominator, all that stuff's multiplied, right? It's much better, much better. What's 2/4? How will that simplify? That's 1/2. Do I need to write the 1? I need to write the 1 if the 1's the only thing left in the numerator. So let's just write it for now because we don't know what's left in the numerator yet. What about this piece right here? When I divide like bases, what do I do to the exponents? I subtract them. Now, here's what I want you to look at. Here's another way to think it. The top has got an x times x, correct? The bottom has only one x. There's only one x left, and it is in the top. Over 2y to the sixth. I don't need that 1 because I did have something else in the numerator. So x times y to the sixth. Crap. X over 2y to the sixth. Stand up, hon. Go get a drink. Go get a drink. Go stand over there. Just walk back and forth. Go get a drink. We're good. It's good. It's fine. We're fine. We got 6 more questions to look at on the other side. Now you'll notice these have a little more stuff to them. No big deal. We can do it. Look at no trig. 3w to the fourth power.
And
I took her words in. All of them.
did you absorb them all of them?
I did. Read with SpongeBob, you know? Yeah, you know they do that. Don't you dare pick on Manny ever again.
Okay. That better stop. All right, here we go. Here we go. Now, we're just going to start one piece at a time. Don't look at it and think, my gosh, there's so much there that I can't even process this. One piece at a time, okay? Huh? Because he's unhappy in the basement. He's going to stomp upstairs. All right. Let's look at this piece right here. We're just going to start small. 3w all raised to the fourth power. What's that going to be?
It's going to be 20.
No. Look. Go to the rules on the front and find one that looks like this.
Power of a product.
Power of a product. So power of a product, what does that tell us to do? 3 to the fourth power, which is 81, times w to the fourth power. So write 81 w to the fourth power. Now we're going to look at this piece. Question. 3 to the fourth power. 3 times 3 times 3 times 3. 81. What about that z to the negative 2? If he's mad in the basement, he's going to go upstairs. So this is going to be Mm-hmm. Times. Now let's look at this piece. Look at the rules on the front. There are multiple rules that this one covers. Put your phone away. But I want you to address power of a product.
What did it just be?
So it'd be
Let's address power of a product. I'm in the right column, second one down.
BW.
A times B, all raised to the m power, is A to the m power times B to the m power. So W to the negative 2 raised to the negative 2 power is going to be W to the 4th power, because you multiply the exponents, W to the 4th power times Z to the negative 2 power. What is the exponent when you don't see one? It's 1.
And Z's gonna have to go down to the basement.
Okay. Or Z can go to the basement and we can take care of him that way. Or I want you to look at this. What's Z squared times Z to the negative 2? When I multiply like bases, what do I do to the exponents? Add them. What's 2 plus negative 2? 0, which is just 1. So this times this is just 1. So this answer is 81 W to the 8th times 1. 81 W to the 8th. You know the rules. Just go one at a time, okay? Look at number 2. Negative 3a all cubed times a to the 9th times a to the negative 7. Which piece do you think you might address first? Address the parentheses first. So let's address this. Now, which rule will address that? Power of a product. So that's going to be negative 3 to the 3rd power. Can you think what negative 3 to the 3rd power is? Negative 27 times a to the 3rd power. Now we're just going to write down everything else. Does that a to the negative 7 need to get stomping mad and go to the basement? Could, but we could do something else, couldn't we? When you multiply like bases, what do you do to the exponents? Add them. So this is negative 27, a to the 12 plus negative 7, or 12 minus 7. Try number 3 on your own. I'm going to do it without talking up here so the people who watch the video can see it. But I'll do it without talking. Let's move on. Number 4. I see some of you already working on it. That's great.
No.
How many questions somewhere?
152.
She didn't say that with any sarcasm.
Do you really think I'd give you that many homework problems?
You know, it's just because Hayden asked. You need their study guide.
But the midterm study guide.
It's like 25 questions.
Okay, because we had so many studies.
All right, let's take a look at this one. There's a lot of stuff going on here. Do you remember dividing fractions back in the day, back when you were just a little kid? Do you remember how to do that?
You have to like take the integration.
You don't have to have common denominators when you multiply and divide, only when you add and subtract. Let's do this. Let's do this. What's half of a half? Half of a half is a fourth. We better figure out how to make that a fourth. No, that's not, no. Zip, back. That would be times, if it was times. Half, because of means times in math. Now, division is funny. When you divide by a fraction, yeah, sometimes not funny, ha, but just funny different. Dividing by a fraction is the same, shush, as multiplying by its reciprocal. Do you remember what a reciprocal is? Yeah, the reciprocal means the numerator becomes the denominator and the denominator becomes the numerator. So this is the same as 1/2 times 2 over 1, which is 2 over 2, which is 1. Because that makes sense, half of 2 is 1.
I thought you divided 2 by 2.
No, punk. That, no, no,
And then
no. So I need you to keep in mind that as we clean this second fraction up, this one here, we're ultimately going to have to multiply by the reciprocal, so don't forget that. Okay, let's look over here at this first fraction. We're raising all this to the -3 power, so let's do the power of a product and the power of a quotient because we've got a fraction. All right. I understand. Can I tell you that there might be an easier way for you to do it? What if I gave you this? What if I gave you 2/3 to the -1 power? Well, no. 2/3 to the first power, but let's look. That would be 2 to the -1 power divided by 3 to the -1 power. Both of them are mad where they are. Right. So the 2 to the -1, he's going to stomp down here and become 2 to the first power, which is 2. 3 to the -1's ticked off in the basement, so he's going upstairs. Yeah, but I'm going to leave it like this. I want you to see that when you have a fraction raised to a negative power, then the fraction just flips. So I think probably the easiest way for you to do that first fraction is to see right here that you're raising that to the -3rd power, so the whole mess is unhappy where it is. So here's what we're going to do. The denominator, he's mad. He's coming upstairs. Now, keep in mind, the denominator's not going to change. He's just going to come upstairs. I know what you're thinking. I'm going to show you. And if you decide, Stennett, that just totally confused me, we'll do it a different way. We'll get it, Isaac. Notice, this exponent right here is the one that told me they were unhappy. That exponent right there told me that the whole thing was unhappy, okay? I didn't change these exponents in here. Now, golly, there's so many different ways you could do this problem. Probably every one of you could take a different path and get the same answer. Let's do this. Let's raise each of those things to the third power. What's this to the third power? X to the ninth. What's this to the third power? What's this to the third power? Negative 2 times negative 2 times negative 2. What's this to the third power? And what's this to the third power? Oh, is that a y? Sorry about that. Thank you. That's a y. I thought that looked funny. Y to the 6. So what have we taken care of? That's done. I bet you don't have enough room on your paper to do this problem, do you? Okay. Now I think it should become easy, I hope. Because we got some things that are ticked off, right? Who's ticked off? Besides Manny? This is ticked off. He's going to stomp downstairs. So they're going to have x to the ninth. That z to the negative 3, he's stomping downstairs and going to become z cubed. Now let's look at the bottom. We have to decide, are the things in the bottom happy where they are, or are they unhappy where they are? X to the negative 12 is not happy. Is the negative 8 happy? Yep. He's going to stay there. And the y to the 6 can stay there. He's happy. The x to the negative 12 stomped upstairs. Now, holy mackerel. What's that numerator? X to the 9th power times x to the 12th power. Say again? No, when I multiply like bases, I add the exponents. That's x to the 21st power divided by negative 8, y to the 6th power, z to the 3rd power. Now, the question you might have is, why did you switch the order of the y and z? We just typically put them in alphabetical order, and that's the only reason. Now, guess what? We still got to do this other one. Oh, okay. So, divided by is that 3 right there raised to the 2nd power? No. Power of a product. I got two things multiplied together that I'm raising to the 2nd power. That's going to be x to the negative what? 14. Times y to the 1 times 2 is 2. Do I have to do anything in the denominator? Let's just write that down. 6y to the 5th, z to the 5th. The x to the negative 14 is mad. He's going to the basement. Would you look at one other thing I could do? What's 3/6? So we're going to do two things. The 3/6 is going to become 1/2. The x to the 14th or negative 14th stomps off to the basement. Now look right here. What's y squared divided by y to the 5th? Okay. There are 2 y's in the top and 5 y's in the bottom, so I'm going to end up with y to the 3rd, but where? In the bottom, because I had more in the bottom, so that's going to be y to the 3rd. Does the z to the 5th stay where it is, or does it move? Z to the 5th's happy. So the 3/6 simplified, the x to the negative 14th moved, the y simplified. What's left in the numerator? Just 1, yeah. Don't say 0, just 1. Ooh. Oh, but dividing by a fraction is the same as multiplying by It's reciprocal, so it's times 2x to the 14th, y cubed, z to the 5th power. Do I need to write divided by 1? You can if you want. Some of you can just watch the video and get caught up. When you multiply two fractions together, multiply the numerators and multiply the denominators, just like normal. How do we multiply these two numerators? How do we multiply x to the 21st times the crap over here? To which one? Now, be careful. Do I distribute? No, because none of these are added or subtracted. So it's just going to be x to the 21st times this stuff. But the only ones you're going to actually multiply are the x to the 21st times x to the 14th. That is not a distribute, because over here I don't have add or subtract. So what have I got? 2x to the 35th, y cubed, z to the 5th. I know this one is tedious, is what you're probably thinking, isn't it? Oh, as long as, if you're thinking a decent word, probably tedious.
Over 8y.
If you can do this one, you can do any of them. All right, so let's look at what we've got. Let's look at what we got.
So it would just be
What's that? That's 1 over negative 4. I don't have any x's in the denominator, so that's going to just stay put.
and then 3x and 3y's left in the bottom.
Y to the 3rd left in the bottom,
And then z to the 2nd.
and then z to the 2nd in the top. Do I need to have that 1? No. 1 times anything is that thing, so I don't need that 1.
Literally terrible.
That was, holy smoke, that was really long. Holy moker. Okay, that was number 4, right?
Yeah, we
That was only
Well, let me tell you that was the roughest one of all of them. That I promise.
I hope so.
I promise. Let's see if we can get through number 5.
It's not even close now.
Oh, number 5. Oh, number 5 is a whole lot faster.
watch this time.
No, number 6.
You have little faith, buddy. I'll watch the video later, right?
Yes.
Y squared. I'm happy if you watch the video, but like over the weekend, not like in 2 weeks or something.
Are you sure to drop a like? Like,
You'll watch the video next semester, okay. Now, here we go. Again, different ways I can do it can all lead to the right answer. Look at that first set there, that first mess. What are you gonna do? Go home? Well, that's not an option right now, but
Multiply by 4, so it'd be x.
so that would be x to the negative 12 over y to the y squared raised to the 4th power. This is y to the 8th power times. Okay, look at that. Look at the second fraction. I'm not raising that fraction to a power. Yay. Yeah. What we're going to do is we're going to start looking at who's mad and who's going to the basement or who's going upstairs. Who's mad? X, yeah. So x to the negative 2 stomps to the basement and becomes x squared and becomes a mean. Okay. Does the y, what does the y do? Stays. And the z cubed, or to the negative 3, stomps to the upstairs. See, I told you this one wasn't too bad.
So for the other side,
Uh-huh.
whatever you put it, not the bottom,
Yep. So we're looking at this right here. What do we have to do with him? He's ticked off. He's going to the basement. What's left in that numerator? Just 1. 1 is left in that numerator. So x to the 12th times y to the 8th times y z cubed over x squared. Let's just multiply across. I've got y z cubed times 1 is yz cubed over what? X to the what? 14th power.
Teachers, please pardon the interruption. I need the following students to come to the office at this time.
Will anything simplify?
Juan Aldaco,
Yeah.
Octavio Ballesteros,
Why?
Hannah
X's,
No.
stay home.
Micah Bland,
Why?
So
John Bowman,
there would be an autopsy.
Natalia Colon,
And then
Aiden
Wait, so what's that? What's the y?
Dozier,
one over X
Warren
14
Dozier,
and y.
Naomi Fernandez, Shelby Gatlin.
And then what about the z's?
Kimberly Gillian, Diamond Johnston, Hayden Eaton, Seth Long, Leighton Spence,